MS Ramaya University of Applied Sciences.
Hello students, let us have a discussion on characteristics of a transistor in common emitter configuration. The aim of this experiment is to study the characteristics of a NPN transistor in common emitter configuration. Motivation to this experiment. Transistor is used in many electronic devices. It is used in semiconductor memories used in computers and mobiles. Transistor find application in amplifier circuits in communication systems. Electronic systems in the vehicles uses transistors. Let us understand the theory behind the experiment before conducting it. A BJT is a 3-terminal, 2-junction semiconductor device in which the conduction is due to both the charge carriers. It is a bipolar device and it amplifies the sine waveform as they are transferred from input to output. BJT consists of 3 terminals: emitter, collector, and base. Emitter layer is a source of the charge carriers and it is heavily doped with a moderate cross-sectional area. Collector collects the charge carriers and hence moderate doping and large cross-sectional area. Base region acts as path for the movement of the charge carriers. To conduct this experiment, we need dual DC power supply, multimeters, resistors 1 kilo ohm and 10 kilo ohm, BJT either SL100 or CL100 or BC107, breadboard and connecting wires. Figure shows the circuit diagram of an NPN transistor used to study its characteristics in common emitter configuration. Figure shows the experimental setup and breadboard connections of NPN transistor in common emitter configuration. Experimental setup is made as per the circuit diagram. To plot the input characteristics, set VCE is equal to 1 volt. Vary DC power supply VBB in steps of 0.1 volt up to 1 volt and in steps of 0.5 volt up to 6 volt, and note down the corresponding VBE and IB readings. Set VCE is equal to 5 volt and repeat the above procedure. Plot the graph between VBE and IB for the two values of VCE. Now, to plot the output characteristics, set IB is equal to 20 microampere. Vary VCC in steps of 0.5 volt up to 10 volt and note down the corresponding VCE and IC readings. Set IB is equal to 40 microampere and repeat the above procedure. Plot the graph between VCE and IC for the two values of IB. Figure shows the expected input characteristics for 3 different values of VCE. Figure shows the expected output characteristics for a number of different values of IB. Limitations of the experiment. Initially, some small current readings can't be observed by multimeter. For some value of current readings, multimeter takes some time to give an accurate value.
Hi students, the name of the experiment is characteristics of a transistor in common emitter configuration, and aim of the experiment is to draw the input characteristic and output characteristics of a transistor in a common emitter configuration. Components required for the experiments are 4 multimeters. In these experiments we are using 4 multimeters. Out of 4, 2 multimeters are used as a voltmeters. One is for input voltage, one is for output voltage, and another 2 multimeters are used for as a ammeter. One is as a input emitter, one is as a output side emitter. Dual DC power supply. This is DC dual power supply, and here you are using both power supply for this experiment. One power supply is used to give a input side voltage, and another side of the power supply is used to give a power supply to the output side of a circuit. Breadboard. This is breadboard. It is used to connect the different components of the given circuit. Connecting wire. These are connecting wires which are used to connect the different components on a breadboard. NPN transistor. This is a NPN transistor having a model number SL100, and it is a 3-terminal device. If you see on its body, one end is having a notch. There is a notch here. This terminal which is near to this notch is called emitter, and after emitter there is a terminal called base in a clockwise direction. After base there is a terminal called collector. Emitter, base, collector. 2 resistors having a value 1 kilo ohm and 10 kilo ohm. This is 1 kilo ohm resistor. Its color code is brown, black, red. This is a 10 kilo ohm resistor. Its color code is brown, black, orange. Let us begin with the circuit connection of a transistor in a common emitter configuration based on the given circuit diagram. Take a connecting wire, and this is a, let us call this voltage source as the input side voltage source for the circuit. So this is the positive terminal of the voltage source. The positive terminal of the source is connected to the 10 kilo ohm resistor. To make this connection, I will connect this wire somewhere in the breadboard like this, and this is connected to 10k resistor. This is a 10 kilo ohm resistor which is connected to this wire, one end. Another end of the 10k resistor is connected somewhere in the breadboard. Take one more wire and connect to the negative terminal of the power supply. This is a negative terminal of the power supply which is connected to the ground. Let us take this bottom line as a ground line. Connect to the ground. Now another end of the resistor is connected to the emitter positive. Let us take this multimeter and connect it as a emitter which has 2 terminals. One is positive, one is negative. Red one is positive, black one is negative. Based on circuit connection, the positive terminal of emitter is connected to the 10k resistor one end. So take a wire, connect to the positive terminal which is connected to the resistor 10k. So I am connecting on a breadboard. And negative of the emitter is connected to the base of the transistor. So connect negative of this emitter somewhere in the breadboard. This point is connected to the base of the transistor. Take a transistor, and if you see the transistor, here is the emitter, base, collector. Based on circuit connection, this base is connected to the negative of the emitter. So this is a negative of emitter which is connected to the base of transistor, and emitter of the, this is the emitter of the transistor which is connected to the ground. I am connecting this to the ground. This is a ground line as I mentioned. So connect to the ground, and collector of the transistor connects somewhere in the breadboard. So now I have connected transistor and the breadboard, and let us take one more multimeter as this and connect this as a input side voltmeter. If you see the circuit connection, it's positive, that is a red probe, a red wire which is connected to the negative of the ammeter or a base of the transistor. So this point in a breadboard. So I am connecting this positive of the voltmeter to this point, and negative of the voltmeter is connected to the ground. So take one wire, connect to this negative, which is connected to the ground. So this is the ground line, connect to the ground. Now we have connected input side 1 voltmeter. So make this as a voltmeter, keep it in a minimum range, and this we have connected as ammeter. So bring it to a DC ammeter position, keep it in a 200 micro position. Now based on circuit connection, collector is connected to a ammeter. So take one multimeter, connect this as a ammeter. So this is the negative of the ammeter. Take a connecting wire, connect to this wire, and which is connected to the collector. This is the collector of transistor, and another end of the ammeter, that is positive end, is connected to the resistor 1K. So take one connecting wire, which is connected to the resistor. So connect somewhere in the breadboard. This is connected to 1K resistor. Take a 1K resistor, one end you connect to this point, and another end of the resistor is connected to the positive of the power supply, which is output side power supply. Take a connecting wire, connect to the this resistor one end, which is connected to positive of the power supply. I will use this power supply as a output side power supply, and based on circuit connection, negative of this power supply, that is output side power supply, is connected to the ground. Take a connecting wire and take this negative of this power supply and connect it to ground. As I told, this line we are using as a ground, so connect it to a ground. Now we need to connect a 1 voltmeter at the output side. Let us take one more multimeter and make it as a voltmeter, which has two ends. One is positive, which is red in color, one is negative. Based on the circuit diagram, a positive of this multimeter is connected to the positive of the ammeter. So this is the positive of the ammeter. So this point I will connect this voltmeter, and negative of this voltmeter is connected to the ground. So take a negative of this voltmeter and connect to the ground. As I told, this is the ground line, connect to this ground line. As I told, this multimeter we are using as a voltmeter. So take it to a voltmeter position, keep a knob in a 200 millivolt position, and this multimeter is used as ammeter. So bring this knob to a ammeter, DC ammeter position, that is 200 micro. Now we have finished the circuit connection of a transistor in common ammeter configuration. So now this is the input side voltmeter, input side ammeter, this is the output side ammeter, output side voltmeter, and otherwise you can call this as this is a multimeter which is used to measure the VBE, base to emitter voltage. This is a base current, and this is a collector current, and this is a collector to emitter current. So based on the procedure, first we have to make VCE, that is collector to emitter voltage, as a 1 volt. So to set this as 1 volt, we have to turn on the DC power supply. Before turning on the DC power supply, make voltage to a minimum value and current set to a maximum value for both voltage source. Then turn on the DC dual power supply. Now I want to set this voltage, that is collector to emitter voltage VC, as 1 volt. To set this voltage I have to vary output side voltage source. So vary it and check here, this voltage is varying. My aim is to make this as 1 volt. So I will go down, increase this, and I will set this 1 volt. Once I set this 1 volt, coming almost 1 volt. Now I won't touch this voltage source, I won't touch this ammeter and this voltmeter. Come to the input side, and this is the input voltage. Now I will vary this voltage in terms of 0.1 volt from 0 volts to 1 volt. After 1 volt I will vary this voltage in terms of 0.5, that up from 1 volt to 6 volt, and I will note down corresponding voltage VBE and corresponding current IB. So for example, if I take VBB is equals to 0 volt, now I am getting a VBE of 4.6 millivolt and 0 microamps, which we tabulate in a given tabular column. Now I will make VBB as 0.1 volt, and for that I am getting a VBE as a 87.1 millivolt and IB as 0.1 microamps, which we will tabulate in a tabular column. And now you increase in terms of 0.1 up to 1 volt as I mentioned, and note down the corresponding VB and IB. So repeat this process till we reach the VBB of 6 volt, and note down corresponding VBE and IB value in a given tabular column. Once we take the readings for a VBB of up to 6 volt, make a VBB 0 and VCC also 0. Next we will repeat the same thing for a VC of 5 volt. Now I will set a VC as a 5 volt. So goes on, increase this. Now we are getting a increase in a value of VC. We need a 5 volt, so I will change this knob to 20. So I need a VC of 5 volt. Now we have a VC of 5 volt, almost 5 volt. Once you set this VC as 5 volt, don't vary VCC and don't touch the IC and VC. Again you come to input side. Now again we will vary this VBB in terms of 0.1 volt from 0 volts to 1 volt. After 1 volt we will vary in terms of 0.5 volt from 1 volt to 6 volt, and note down the corresponding VBE and IB reading. For example, now I will make VBB as 0.1 volt, and for that I am getting a VBE of 106 millivolt and IB as 0.1 microfarad. And next we will make it 0.2, note down the corresponding VBB and IB reading. Then you make it 0.3, 0.4, like that you note down all the readings for VBB, VBE and IB. Now we have took two sets of reading for a input characteristic, that is with VC equals to 1 volt and with VC equals to 5 volt. Now we will start to take a reading for a output characteristic. So before that, make voltage source value as 0 volt, both voltage source set to 0 volt. Now this is VBE, this is IB. So to draw output characteristic, I have to set IB as a 20 microamps. To set this IB as 20 microamps, so I have to change a voltage source VBB. So vary this VBB. Now you can see some voltage, some current is changing in this ammeter. You set it as a 20 micro. So by using this voltage source, I will make it as 20. Now I have set IB as a 20 microamps. Once you fix input side current, that is IB as 20 microamps, don't vary the VBB. Now come to the output side. This is the output side applied voltage, which is VCC, and this is VCE, this is IC. Now start increasing VCC value from 0 volts, vary in terms of 0.1 volt up to 1 volt. After 1 volt, vary in terms of 0.5 volt up to 6 volt. Note down corresponding current IC and corresponding voltage VC. For example, now VCC is 0 volt and we are getting IC as minus 2.6 microamps and VC as 0 volt. So keep this voltage in a minimum position. Okay. Now let us make VCC as 0.1. As I told, vary this in terms of 0.1 up to 1 volt, make this as 0.1. For the VCC of 0.1 volt, we are getting IC as 64.7 microamps and VC as 93.2 millivolt. And next vary this in terms of 0.1, that is make it 0.2, and for that corresponding IC is 108 microamps and VC is 146.6 millivolt. Note down these readings in a tabular column and continue this variation of VCC, that is vary in terms of 0.1 up to 1 volt. After 1 volt, vary in terms of 0.5 up to 6 volt. Note down corresponding IC and VC in a tabular column. Once we took all reading for a IB equals 20 microamps, next we have to repeat the same process with IB equals to 40 microamps. To make that, first to make both voltage source value as 0 volt, then again you set this IB value as 40 microamps. So using this voltage source, make this IB as 40 microamps. So this is, now I have set the input current which is IB as 40 microamps. Now again I will vary this VCC in terms of 0.1 volt from 0 to 1 volt and I will note down corresponding current IC and VCE and note it on a tabular column. For example, for a value of VCC as 0.1 volt, I am getting IC as 78.8 microampere and VC as 98 millivolt, and note down these values in a given tabular column. Now goes on increase this value in terms of 0.1 up to 1 volt. After 1 volt, vary in terms of 0.5 up to 6 volt. Note down corresponding value of IC and VC in a given tabular column. Now we have done with the circuit connection of a transistor in a common emitter configuration, and we have 4 sets of reading, that is 2 sets of reading for a input characteristic and another 2 sets of reading for a output characteristic. Based on these readings, we will plot a input characteristic and a output characteristics of a transistor. By this we are done with the BJT characteristic of a transistor in a common emitter configuration.
At MSR UAS, we spark your imagination unlike any other.